Hi, I'm JD. In this lecture, we're going to go over whole numbers, integers, and the basics of algebra.
And here is a preview. We're going to go over the sign rules, operations, and that includes absolute value, exponents, just to get you a little familiar with them. Order of operations, please excuse my dearest Aunt Sally. Expressions, those are things that have numbers and variables but no equal sign. And lastly, we're going to go over equations, not in depth, just the additive property of equality. So let's get started. So sign rules. So with the sign rules, addition and subtraction are a little bit more complicated in comparison to multiplication or division. And I would view addition and subtraction separately, even though they're together. So with addition, the signs and rules are, if they're the same sign going in the same direction, that means both positive or both negative, you're going to add the numbers together and keep the sign, whatever that is. If they're unlike signs, that means they're going in different directions. Then what you're going to do is you're going to take the difference of the two and keep the sign of whichever one's further away from zero, whatever is the larger number. And then subtraction, what you can do with that is just change it to addition. Subtraction is just adding the opposite. And then you would apply, once you change it to addition, you can just apply the addition rules. Then with multiplication or division, the sign rules are easier. Basically, you ignore the sign, you perform the operation, and if the signs are the same, then positive. If they're unlike signs, then negative. So let's go through some examples. 7 plus 3, I think you know how to do that, that's 10. But let's look at the sign rules. Both of them are positive, so they're both going the same direction, so you would add them together, keep the sign, so that would be 10. Next one, 3 plus negative 7. Okay, those signs are opposite. They're going in different directions, so you're going to take the difference of the two, which would be 7 minus 3, which would be 4. And since the negative 7 is further away from 0, technically negatives are always smaller than positive, but that's why I had the larger in quotes, because really you ignore the sign and just say which one's larger, and here it's 7, so the result's going to be a negative 4. Do the same with the next one, negative 3 plus 7. Take the difference of the two, so 7 and 3, the difference of that would be 4. 7 is larger, so that would be a positive 4. Negative 7 plus a negative 3. They're both going in the same direction, so same sign. So you're going to add them together. That would be 10, and you're going to keep the sign, which is going to be a negative 10. 7 plus 0. Anything plus 0 or 0 plus anything is just the anything, so it would just be 7. And then negative 7 plus 7, since you're starting off with 7, you just, well, take the difference to would be 0, and it doesn't matter what the sign is because 0 is not positive and it's not negative. So now what you can also do when you're thinking about these sign rules or addition or subtraction, you can think money. So if I start off with $7, I gain $3, that's $10. If I have $3 and I lose $7, I'm now in debt $4. So you can think of debt as negative and money that you have as positive. So negative 3 plus 7, that would be you're in debt $3. You gain $7. You now have $4 in your bank account. Negative 7 plus 3, negative 3, you're in debt $3. You lose $3 more dollars. Now you're in debt $10. Now these are hypothetical. We know that if you bounce a check or whatever, you're going to get additional fees or whatever. But anyways, so $7, you gain 0, you still have $7. If you're in debt $7, you gain 7. Now you break even. You're now at $0. I guess 0 is better than negative. Anyways, example number 2. So these are subtraction. What you can do with subtraction is just change it first to addition. And subtraction is just adding the opposite. So if I have 5 minus 6, I can take that, change the subtraction from subtraction to addition, and then since that's a positive 6, you make it a negative 6. Then the sign rules apply. So there are different signs. So you would go in opposite directions, right? So you're subtracting 6 minus 5, so that would be 1. And then negative is further away, so that would be a negative 1. Or just think money. You know, $5, you lose $6, now you're in debt $1. So 6 minus 5, I think you know how to do that. That's just 1. But you can see how I demonstrated how you would change that from subtraction to addition. Now 5 minus negative 6, that's a little tricky, but if you know that subtraction is adding the opposite, so adding the opposite of negative 6 would be a positive 6. So you would actually add 5 plus 6. I know you know how to do that. That's 11. Negative 5 minus 6, well, you can change it to the subtraction to adding the opposite. So it'd be negative 5 plus a negative 6. They're going the same direction. So you would add them together and keep the sign, which is negative 11. All right, so now let's look at the sign rules as they pertain to multiplication and division. And they're going to be the same sign rules. So if the signs are the same, if they're like signs, positive, unlike signs, negative. So 6 times 6, calculate it first. So that would be 36. Is that positive or negative? Since the signs are the same, it's going to be positive. Negative 5 times a negative 6. Ignore the signs, so it'd be 5 times 5, which is 25. And since the signs are the same, it's going to be positive. Negative 18 times 5. Calculate the numbers first. So 18 times 5 is 90. And since the signs are different, it's going to be a negative 90. Now 1 is kind of like the same when you're adding, with 0. So 1 times anything is just going to be anything. So the result here is going to be 1,754. Then you have 0, and 0's, when you're multiplying by 0, 0 is kind of unique when it comes to multiplication and division. So you have negative 165 times 0. Anything times 0 is just 0. Now let's look at division. Now I put some fractions in here because the fraction bar acts like a division sign. Now sometimes you might see this on the computer as a slash mark. It does the same thing. So 36 divided by 36, division is just asking how many times does that second number go into the first number. So 36 goes into 36 once. Now is it positive or negative? Well, it's going to be positive because the signs are the same. 21 divided by negative 3, so how many times does 3 go into 21? 7 times, and it's going to be positive or negative. Since the signs are different, it's going to be negative. So it would be a negative 7. So negative 19 over 1, that's the same as negative 19 divided by 1. So when you divide anything by 1, and multiplication is kind of the opposite, so you're going to end up with the same. Which kind of makes sense. 1 goes into 19 how many times? 19 times. Now, is it going to positive or negative? Well, the signs are different, so it's going to be negative. Negative 18 over negative 3. 18 over 3, or 18 divided by 3. 3 goes into 18 6 times. Since the signs are the same, it's going to be a positive 6. 51 divided by 0. Well, how many times does 0 go into 51? Well, that doesn't make any sense. So that would be undefined. And whenever you spell no, it's undefined. So any number divided by 0 is going to be undefined. 0 divided by 13 is going to be 0. This one kind of makes sense. Not the best sense. Because if you have, let's say that you have 0 donuts and you want to split those between 13 people, you can do that. Everyone's going to get 0 donuts. So it's not the best, but you know, it kind of makes sense. So 0 divided by any number is going to give you 0. So when it spells on, or if it's on, it's okay. It's okay because it's 0. It's the way that you can remember that. So no way, Jose, undefined. If it spells on, it's a-okay, 0. All right, so now let's look at some operations. So we have absolute value. And when it comes to absolute value, if I'm going too fast, it's probably because of the coffee. But you can always pause it. So when it comes to absolute value, you want to think distance. Distance, the distance away from 0, or any number away from 0, is going to be positive, right? Think distance. You always think positive. You don't say to your, family and friends, well, I'm negative 15 miles away from home. When referring to distance, it's always positive. So that's the way to think about it. So the absolute value of 14 would be a positive 14. The absolute value of 0, since the distance away from 0 is 0, you haven't moved anywhere, would still be 0. Negative 14, the absolute value of negative 14. Negative 14 compared to 0, that's 14 units away, so that would be 14. The absolute value of negative 5, negative 5 is 5 units away, is 5. Now, you can think about this as like, okay, if there's a number in there, I'm just going to make it positive. And you can do that. So, whatever number is in the absolute value bars, it's going to make it positive. All right, so now let's look at exponents. And exponents is really a shortcut for multiplication. So if I do 5 squared, that's 5 times itself twice. And 5 times 5 would be 25. Negative 5 squared, that would be negative 5 times itself twice. So that would be negative 5 times negative 5. Multiply it first, so 5 times 5 is 25. Then do the sign rule. Since the signs are the same, it's going to be a positive 25. Letter C is different from B. So what's going on with C is only the 5 is being squared and the negative is coming along for the ride. And what you can do with that negative is that you can make it into a negative 1. And then that 5 squared is 5 times itself twice. So what you have is negative 1 times 5 times 5. So order doesn't matter when it comes to multiplication. Same with addition, or doesn't matter. So you can switch around. So I can do 5 times 5 first, which is 25, and then times the -1, which gives me a -25. Letter D is raised to the 4th power. So that would be -5 times -5 times -5 times -5. Because you're multiplying -5 times itself 4 times. So ignore the signs. So 5 times 5 is 25 times another 5 is 125 times another 5 would be 625. So you have 625, and is it going to be positive or negative? Well, what you can do is take the operation or the signs 2 at a time. So you have negative times negative, which is positive, times another negative, that would be the third one, makes it negative, times another negative, which would be the fourth one, which makes it positive. So you end up with a positive 624. Now, if you notice B and D, where you have -5 and it's being raised to an even power, both are positive. So whenever it's an even power, it's going to be a positive result. Now this differs with odd. So -5 raised to the 3rd power, that would be -5 times -5 times -5, which is 125. But is it going to be positive or negative? Well, again, you can do 2 at a time. So negative times the negative is positive times another negative, which will make it negative. But you can also remember that if it's odd, it retains its sign. So if you have an even power and you have an exponent, the result is positive. C is not the same. We already looked at that. Only the 5 is being squared there. So whatever it's attached to. And then with -5, parentheses, that's telling you that the -5 is being raised to the 4th power. So whenever it's raised to an even power, it's going to be positive. When it's odd, it retains its sign. So if you had like a 5 raised to the 3rd power, it would be positive 125 because it's a positive 5 that you're raising the 3rd power to. So odd retains its sign, even always positive. All right, so now let's look at the order of operations, PEMDAS, or if you have an Aunt Sally, please excuse my dearest Aunt Sally. Now here's the order, and we're going to look at an example so that we can see how this works in a very complicated example. So P stands for parentheses or grouping symbols. Grouping symbols could be like absolute value bars, square roots, so they don't necessarily have to be parentheses when you're parentheses and grouping symbols are the same. Exponents, anything raised to a certain power, so you do all the parentheses first. Within the parentheses, the order of operations apply, and then you do all the exponents. And then once you finish with the exponents, it's multiplication or division from left to right. So if you see division first from left to right and then multiplication, you have to do division first. And then after all the multiplication or division from left to right, then you do the addition or subtraction from left to right. And again, if subtraction, you see it first, when you're reading from left to right, you have to do subtraction first and then addition. It's whatever you see from left to right. Now, multiplication or doesn't matter, but with division, it does. So, but if you have a string of multiplication, you can kind of choose what you do first. But, you know, and same thing with addition, but with division and subtraction, order does matter. And with the order of operations, order of course matters. Sometimes you can get away with doing a little bit out of order. sometimes. All right, so let's look at an example. So you're told to simplify this. You have negative 3 squared plus 36 divided by 9, parentheses, 52 minus 25 times 2, close parentheses, open parentheses, negative 4, close parentheses, raised to the second power. So if you're kind of rusty on order of operations, what I would suggest is to write it down. When you're working out these problems, kind of remind yourself of the order. Now, with parentheses, if they end up being more complicated, then you have to work inside out. And again, the order of operations apply. So you look inside the parentheses, you have multiplication, so you would multiply first. So 25 times 2 is 50. Still have to simplify what's inside the parentheses. Notice everything else is just being brought down is the same. So continue to do what's inside those parentheses. So 52 minus 50 would be 2. Then you already did the parentheses. The negative 4 in parentheses is just a sign holder. So that's technically x in exponent. So you do exponents next. And since they're so separate, you can do them at the same time. So 3 squared is 9. The negative comes along for the ride. Negative 4 squared, negative 4 times negative 4 gives you the positive 16. Now you want to do multiplication or division from left to right. So you have to do that division first. So that would be 36 divided by 9, which gives you 4. Still do multiplication or division. You have multiplication, so let's do 4 times 2, which is 8. Next we'll do 8 times 16, which is 128. And then you have negative 9 plus 128. So you're adding them together. Signs are different. So you take the difference and keep the sign of whatever is larger. You keep the sign of the 128, which gives you 119. And that's it. All right, so now let's look at, and this is kind of, one topic after another. If you need a pause, then do so. So translating into algebraic expressions. So you have four operations, addition, subtraction, multiplication, or division. And here are the words. So if you have sum, as in sum total, that would be addition. If you see difference, that would be subtraction. You would translate it to a minus sign. Product, that is multiplication, and quotient is division. Now when it says sum, difference, product, quotient, that's in reference specifically to the results. And usually you're going to see sum, the numbers separated by an and, difference separated by things in an and product separated by an and quotient separated and then an and. Well, the way that you would translate it is in the order that you see it. And you all already know plus, minus, and times, and divide. Some of these are obvious. Of, you would always translate into multiplication. And if you see more than or less than, more than would be plus, and you have to switch the order technically. Technically, you have to switch in the order, but it doesn't matter in the long run because it's plus. So since you're adding, or does it matter? So if you translate it and you're told, oh, you have to simplify it, you can still get it right because the order doesn't matter. With subtraction, it does. So when you see less than, you have to switch the order. So 2 less than 4 would be 4 minus 2. Twice, if you see the word twice, then that's 2 times whatever. You might see thrice, but I don't think so. Thrice would be 3 times. All right, so let's translate. So part A, it says 5 more than 8 times a number. And let's say a number here is x. So more than is separating the 5 and 8 times a number. So 5 is separating, or the more than is separating the 5 and 8 times the number. So 8 times the number would go first because the more than switches the order, so that would be 8x plus 5. Now part B, the quotient of a number in 7 decreased by twice the number. The quotient is in reference to division, and like I said before, if it's sum, product, difference, quotient, it's in the order that you see it. So that would be x divided by 7, decrease is subtraction, so that would be x divided by 7 minus twice the number, which would be 2x. So it would be written like that. All right, that's briefly how you would translate words into algebraic expressions. So let's continue on this topic of algebraic expressions. So what are they? Well, they're made up of constants and variables. You can tell that it's an expression because it doesn't have an equal sign. So you're not solving. Directions are commonly to simplify. And simplify just means combine like terms, perform order of operations, etc. When they tell you to evaluate, what they're telling you to do is to substitute. So simplify, you're going to simplify it as much as possible. And it could be a number, it's just going to be another expression. And then when you're told to evaluate and you have to what they're telling you to do is substitute, then what's going to happen is you're going to end up with a number. So here they're telling you to evaluate. So whenever you evaluate, what you want to do first is you want to rewrite the expression, or rewrite whatever you're plugging into. So that would be x minus 2 parentheses y plus 3. Next step would be to substitute. If you see a negative number, substitute using parentheses. If it's just a positive number, then you can just substitute it in. The key is to be consistent with your operations. And what I mean by that is if the number is right next to the variable, and that means multiplication, then when you substitute, that same operation has to be there. It's important to be consistent. So x you're replacing with -2. Here I put the parentheses in there, but you don't really have to because it's out front there. But it's just a good habit to have, because then you can see what you would need to do. And sometimes if you have a negative, it might be confused with a minus sign. Negative is a sign, minus sign would be an operation. So now you just apply the order of operations. So you do what's inside the parentheses first. So you do 3 plus 3, which is 6. You have -2 minus 2 times 6. So now you would multiply. So you do 2 times 6, which is 12. And then -2 minus 12, which is -14. And that's it. So let's look at another example. Whoops. I guess that was it for examples. Here's another expressions. Now, so when you're simplifying expressions, two things to remember. One is the distributive property, and I'll show you how that works. Distributive property is multiplication over addition or subtraction. So whatever is being multiplied, you share it to what's inside those parentheses to each term. Now, combining like terms is another way to simplify an expression. Remember, apples with apples and bananas with bananas. So if you look at my example, you have 2a plus 3a plus b plus 5b. So 2 apples plus 3 apples equals 5 apples. A banana plus 5 bananas equals 6 bananas. So you have 5 apples plus 6 bananas. So apples with apples and bananas with bananas. Now, notice with the b, you can rewrite that as 1b. So if you see an x or b, so if you see an x, that's the same as 1x. If you see a b, that's the same as 1b. And sometimes you would want to rewrite it to make things easier on yourself. Now, if you have to choose between 1x and x to put your final answer, you'd put the x because x technically is more simplified. All right, so example 10, we're going to simplify this expression. So you would start by doing the distributive property to the 7 to the x and the x squared. So you get 7x plus 7x squared plus 11x minus 13x squared. At this point, you can add like terms together, but something that you might want to consider is to rearrange it. So put all your x's together and put all your x squares together. So then you would combine like terms. So 7x plus 11x is 18x. 7x squared minus 13x squared is negative 6x squared. So we have 18x minus 6x squared. Now, am I done? The answer is yes. I am done. X and x squared are different. They're unlike terms. So you wouldn't be able to combine them. So it's always apples with apples, bananas with bananas. You can't combine an apple and a banana. Well, you can combine it in a smoothie, just not in math. All right, so now let's look at equations. So we're going to break this apart in weeks, and so we're going to first look at the addition property of equality. So first, what you want to consider is what operation you're doing, and you want to do the opposite. And something else you want to consider in general is whatever you do to one side, you do to the other side. It's like a balance. So whatever you're adding on one side, you want to put on the other side to keep balance. And the way to think about this property in particular, is you add or subtract both sides. So let's look at a couple of examples. So first you would, it's asking you to solve it, and there's an equal sign here, so it's an equation. So first you want to distribute the 4, you want to simplify it. So you have 20x minus 8 equals 19x plus 4. Now next, what you want to do is you want to get rid of the x. Now, which one do you decide, the 20x or the 19x? It doesn't really matter which one, but at this point, what's going to happen is one's going to cancel out, the other one is when you add or subtract them, it's going to give you a 1x. So you want to do what's going to give you that 1x. And so you would subtract 19x from both sides. So you end up with x minus 8 equals, now the 0 is coming in because you have 19x minus 19x, and that gives you 0. Now you don't have to put the 0 in here. I'm just showing you what you're trying to accomplish. Because you're trying to get x by itself, more and more by itself. And by getting rid of that term, it's going to do that. So 0 plus 4 is just 4. So now I have x minus 8 equals 4. I want to get rid of that minus 8 because I know that if I get rid of that, then x will be all by itself. So the opposite of subtraction is adding. So I'm going to add 8 to both sides. So when I do that, I end with x plus 0 and then 4 plus 8 on the right hand side, which is 12. Now x plus 0, that's what I wanted because x plus 0 is just x. So my final answer is x equals 12. Now this is a very longer way to do this and probably more work than you need to do on your paper. But when you're adding or subtracting, the goal is to get one side, that to zero out, because when you zero it out, you end up with just, 0 plus anything is just the anything. And you want it to get more and more by itself, the variable. So you want to shift all your variables to one side and then all your numbers to the other side. All right, so now let's look at another example. Let's start by distributing. So we're going to distribute the -2. Notice you have -2x plus 6 because -2 times a -3 gives you a plus 6 or a positive 6. Now, since it's a subtraction sign, it ends up turning to positive, which would be making it a plus sign. Now, what are you going to do? Are you going to add 2x to both sides, or are you going to add x to both sides? Well, you want a positive 1x, so you would add 2x to both sides. Now, what you can do as well is, since you're moving all the x's to the right-hand side, you can move all your numbers to the other side, which means that you would subtract both sides by 5. And you can do that in the same breath, same line. And so the -2x plus 2x, that cancels. 6 minus 5 is 1. -x plus 2x, that gives you 1x, which is the same as x. And then 5 minus 5 cancels out. So that leaves you with 1 equals x. And that is the same as x equals 1. You don't have to put that extra line in there. I just wanted to show you that 1 equals x is basically the same as x equals 1. So sign rules, addition and subtraction. You have, if the signs are the same with addition, then you add them together. If the signs are different, then you take the difference of the two, and whichever one's the larger one with quotes, whichever one's further away from 0, you keep that sign. With subtraction, you can just change it to adding the opposite. With multiplication or division, the signs rules are if they're the same sign, then it's positive, unlike signs negative. Absolute value, think distance. Exponents is just a shortcut for multiplication, so 5 squared would be 5 times itself twice. Order of operations. Please excuse my dearest Aunt Sally. Parentheses are grouping symbols, then exponents, then multiplication or division from left to right, and then addition or subtraction from left to right. Then translating phrases. Watch out for the more than and less than, right? More than is plus, but it switches the order, and less than, which you have to be more concerned about, is subtraction, and it switches the order. Evaluating expressions, that's the same as substitution. Simplifying expressions, that just means that you're making it an expression more simplified. It still has variables and constants. Constants is just a number that doesn't have a variable attached to it. And then solving equations And here we just went over the addition property. Whatever you add or subtract, whatever you do to one side, use the other side. And that's pretty much it.
Thanks for watching this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below.